Hi guys, Justin here from chemistrynotes.com, and this is the very first video from the very first section of General Chemistry Notes. So, the primary function of this very first video is to take you through the scientific method. But before we do that, and we'll get started here on page 2 of our notes, I first need to introduce to you the point of view of the macroscopic world versus the point of view of the microscopic world, because chemistry, and specifically general chemistry, we spend almost all of our time discussing the microscopic world. Almost the entire course of general chemistry can just fit in the palm of my hand, or even on a few fingertips. So we're talking about very, very small stuff. But everyday life, we exist in the macroscopic world. So I'm going to start off by making comparisons between those two. So let's get started. At the top of page 1 of our notes here, it says Section 1. So Section 1 is kind of like Chapter 1. Section 1, Foundations of Chemistry. One of the main challenges of chemistry is to understand the connection between the macroscopic world that we experience and the microscopic world of atoms and molecules. As an example, all right, we've all been on an airplane. Very few of us have been on a helicopter. But if you ever look at a sandy beach from a really, really far distance, it just kind of looks like a single, continuous, solid, tan-colored substance, right? Up close, however, a sandy beach consists of unique, individual grains of sand, right? We've all held grains of sand in our hands, and even then we're still at a macroscopic point of view, by the way, but every one of those same grains of sand looks a little bit different. Furthermore, each of these grains of sand are themselves individual silicon atoms and oxygen atoms, okay? And those guys are connected together by bonds. All right, so you got one point of view where it's just a big sandy continuum of tan color, and then another point of view, the microscopic point of view, where it's individual silicon atoms and oxygen atoms connected by bonds. Two totally different points of view. Another example is the tremendous variety of substances in our universe. All right, the millions and millions of different substances and compounds and molecules are made from only roughly 100 to 110 different kinds of atoms. Right? If you ever look at the periodic table, there's not that many elements, right? Just over 100, okay? Well, compare that to the 2 million words in the English language, right? We make up those 2 million words from only 26 letters in our alphabet, okay? So what I'm trying to emphasize here is that we have a macroscopic point of view, everyday life, you, mom, dad in the supermarket, for example, versus the microscopic point of view, where everything we're looking at is microscopic and even submicroscopic in size. Okay? So, I'm about to get started on scientific method, but I do want to make a little bit of an introduction here to the scientific method. So, bear with me. Page 2 of our notes, we have a little bullet point there, and it says, to understand the relationship between the macroscopic world and the microscopic world, and to study nature, and to study science, and to study general chemistry, for example, scientists use a process, and this process, as you probably guessed, is called the scientific method. All right, so we're going to go through the scientific method. This process is roughly the same no matter where you look at it or where you receive the information on it, but it's essentially a series of steps, a series of processes that a scientist or a chemist will go through when they're going through research, okay? So the scientific method. Definition of the scientific method is the process that lies at the center of scientific inquiry, okay? It's the process that lies at the center of scientific inquiry. All right, the scientific method has 5 general steps. And the first step in the process, all right, so we're going to have a number 1, a number 2, a number 3, a number 4, and a number 5. First step, number 1, is making observations. Sometimes making observations is also referred to as collecting data, or making observations and collecting data. I just call it making observations. There are two types of observations. Okay? Qualitative observations are descriptive characteristics, color, texture, things like that. Quantitative observations are often referred to as measurements. They involve calculations, they involve using some sort of measuring device and to write down the data when you capture that particular amount or of material, etc. So qualitative observations describe characteristics. Quantitative observations are measurements. And measurements involve, by the way, not just a number or a value, but more importantly, actually, also a unit. Number two, formulating a hypothesis. So after we make observations and we collect data, we develop an opinion and we begin to formulate a hypothesis. Formulating a hypothesis is also referred to as kind of making a prediction. Let me define hypothesis for you. Hypothesis. It is a possible explanation for an observation. So it's your possible explanation. You haven't tested it. It's not tested, tried, and proven. It's just what you think right now in step 2. So formulating a hypothesis is a possible explanation for the observations you've been making. So you're going to test that hypothesis in process number 3, or step 3. So step 3, performing experiments. In other words, testing your hypothesis. Now, when you perform these experiments usually lead to brand new, unexpected observations, which brings us back full circle, right? That moves us back into step 1, where we begin to make new observations based on those brand new observations. So it kind of brings the process back to step 1, and we go through this ritual of going through step 1, observation, again through step 2, formulating a new or an abridged hypothesis, and then we test that new hypothesis through a series or a set of new experiments. So 1, 2, 3 you can cycle through for a while, and the process repeats until you reach a breakthrough. So process repeats until a breakthrough is reached. Now, after the dashed line, see the dashed line I have here? That's my way of showing you visually. Finally, we have a breakthrough, and we move out of the step 1, step 2, step 3 cycle, and we move into step 4, which is below our breakthrough, below our dashed line. Step 4, assembling hypothesis into a theory. Okay? So let me rewrite that so I have more room. I'm going to move to a new page of notes here. I'm just going to rewrite step 4. This is assembling our hypothesis into something called a theory. All right? So let me double underline and define theory for you. I've defined scientific method. I've defined hypothesis. Now I'm going to define theory. Got two definitions here. Theory is an accepted explanation, or it's a set of tested hypotheses that gives an overall explanation of why nature is behaving in a certain way. So theory, it's an accepted explanation, or it's also defined as a set of tested hypotheses that gives an overall explanation of why nature is behaving a certain way. Okay? So step number 4 kind of morphs itself into step 5 here over time. Okay, when that theory has been observed in many different situations under different types of circumstances, and it still holds true. When the theory is observed in many different situations and is generally starting to be taken as fact rather than just an accepted explanation, that theory becomes a law. Okay? So a theory becomes a law after it's been observed in many different situations and it generally is now taken as fact. Okay? Now let me define law for you. Law, in terms of the scientific method, is a factual summary of observed behavior. All right? And I just want to make a little note here. And that note is essentially on steps 4 and 5 that you see above you on this same page. It says, theories are just explanations of observed behavior. A theory is an explanation of the hypothesis or hypotheses you have made. Okay? They're not accepted facts. Once they're accepted as facts over time and after they've been tested and they stood to be true, then it becomes law. All right, let's do an example. Now, this example, it would be an example of the scientific method just kind of used in everyday life. Now, listen, let me set this up, okay? Imagine that this is your grandfather or your grandmother trying to get to campus, okay? Before Google, before cell phones, before internet, okay? Probably I should update this example, but you get the idea and it's a great example, okay? So I want to leave it here. Makes no sense to you guys now. It makes sense to me because I'm 46 years old. But imagine it's your grandfather or your grandmother, right? Here we go. You're a freshman, your grandmother or grandfather is a freshman in college, and it's your very first day of class. Let's assume you are truly a freshman, totally confused, and you don't even know how to get to the university. Okay, it's going to be a long week, right? You're a freshman in college, and it's your very first day of class. Let's assume you're truly a freshman and you don't even know how to get to campus. Okay? First, you might buy a map and look up possible routes. Okay? That's first. Next, you could ask people familiar with the area, familiar with the surroundings near campus. You could ask people familiar with the area about the advantages and also about the disadvantages of the various routes that you may or may not have noticed by using your map. So let's take it from the top. First, you might buy a map and look up possible routes. Okay? Observations, collecting data. Next, you could ask people familiar with the area about the advantages or disadvantages of the various routes on your map. Again, making observations, maybe even making a new hypothesis at that point. Okay? Or maybe you're still in the phase of you're collecting data and you're making observations and you haven't made a hypothesis yet. Remember, steps 1, 2, and 3 repeat. Nothing is really etched in stone. Okay, third bullet point. After getting your information, right, after collecting your data, either from the map or from other people who know the area better than you, you now predict the best route to campus. Okay? Once you predict your final best route, because you may have had some other best routes ahead of time, once you get the actual what you think is your best route to campus, you formulated your hypothesis. Okay? However, you can only find the best route by actually testing those routes, going on each of those routes individually to see which one is the best route. In other words, that final bullet point, that fourth little dash there on this page, you're testing your hypothesis. All right, top of the next page of notes, we're getting towards the end here. We're making our way closer and closer to campus. We've tested different routes to campus. So it says here, there's a little star there. It says testing the hypothesis. You've taken these routes, you've walked them or driven or rode your bike, and you found out which one you think is the best, you assemble it into a theory. Okay? And if you end up taking that route for all 4 years you're in college, well, then that theory finally becomes a law. It truly was the best route. All right. In the next section, this is going to be section 1, video number 2 from section 1, Foundations of Chemistry. We're going to talk about units of measurement. It's a lot different than this video, and there's math involved, so you might want to have a calculator, or you can just go ahead and watch. It's up to you. You can watch this as much as you'd like. So stick around. Video number 2 is coming up next.